All right, here we are in lesson 6.3, part 2. In the first lesson, we learned about using the area model to represent the multiplication of two binomials. And so today we're going to expand upon that so that we don't necessarily have to draw a picture every time. The picture is great, especially for those of us like if what we do today, try it, but if it feels uncomfortable, then you're welcome to continue to use the area model that we used. But I think we can get to a place where we don't need it, so we should try. So to get started, let's go ahead and do the area model on the first one, okay? So let me draw out my model. And we're going to say this is x and this is 3. And then we're going to say this is 2x and this is 1. Okay. Now, what I want you to notice, well, let's just do the area here. 2x times x is 2x squared. 2x times 3 is 6x. X times 1, I'm sorry, what am I doing? X times 1 is x, and then 3 times 1 is 3. All right. So here's what I want you to notice. I want you to look down this column here. And let's look at the math we just did. We took the x value, which happens to be this term right here, or this piece of that one. And what did we do? We multiplied it by 2x, right? We did x times 2x to get 2x squared. And then what did we do? We did x times 1 to get x. So all I really did here is a distributive property. I took x, the first piece of the first binomial, and I multiplied it by 2x plus 1, right? X times 2x, x times 1. X times 2x is 2x squared. That's what we got there. X times 1 is x. Then what did we do? Well, then we took the 3 and we multiplied 3 times 2x, and we did the 3 times the 1. In other words, I did the 3 times 2x and the 3 times the 1. So I did another distributive property. So this is a positive 3, so I'm going to put a plus 3 times 2x plus 1. So all I did in doing my table is I just organized the fact that I have to do, in this case, two distributive properties. I had to take the x times both of the second binomial and the 3 times the second binomial. 3 times 2, I get plus 6x. Positive 3 times 1 is plus 3. I add them together, I get 2x squared plus 7x plus 3. That is the answer we would get with the area model. So let's look at part B. All I'm going to do is distribute the 4x times 2x and times 5. 4x times 2x is 8x squared. 4x times 5, 4 times 5 is 20x. Then I'm going to take the second part and I'm going to distribute that. Negative 3 times 2 is negative 6x. Negative 3 times 5 is minus 15. I can combine the middle terms together. And that is exactly the same math as if we had done our area model. Especially if I multiply it down the column. 4x times 2x is 8x squared. That's what we have right here. 4x times 5 is 20x. That's what I have right here. Negative 3 times 2x is negative 6x. And negative 3 times 5 is negative 15. So once again, the area model is just a way to help us organize the various multiplications we need to do. Okay, so one way to look at this is as we just did as a distributive property. Another way to think about it to help organize your making sure you did all the math you need to do is this acronym known as FOIL. So we talk about the FOIL method. And FOIL stands for first, outside, inside, last. So what does that mean? Well, when we look at multiplying two binomials together, so I'm just going to say like A plus B and C plus D. First references multiply the two first things together. So that would be doing the A times the C. That's your F for first. Then you have outside. So what are the outside? So thinking about this as two things bunched together here, then the outside would be this A is on the outside and this D is on the outside. So that's your O for outside. But notice, what is that? That's just doing A times C and A times D. It is just distributing A just like we just did. The inside refers to the two on the inside. So the B and the C are on the inside. That's your I. And then L references, sorry, my screen just went to sleep and it's back. And the L references multiplying the two last ones together. So the last one would be the B and the D. So that's your last. But what is that? That's just doing B times C and B times D. That is just the distributing of B through the second polynomial. So when you say FOIL, we're really just talking about doing the distributive property. But you will hear me say use FOIL, use FOIL, use FOIL. Really, I'm just telling you to make sure you have multiplied both of A and B times both of C and D. That's what we have done. So it's just another way to organize this math that we're doing, whether you use the area model, where you think of it as a distributive, or whether you think of it as FOIL, it all is telling you to do the same thing. And what is that? Multiply both of the first two with both of the second two. So there's a total of 4 multiplications going on. All right. Hopefully this is okay. Let's go ahead and on your own, try C, and let's think of it as FOIL. So I'm going to use little arrows here. FOIL, do the two firsts together. X times X is X squared. The outside, X times negative 10, negative 10X. All right, FOI. So now I'm going to do the inside ones. So negative 5X, and then I'm going to do the last ones. And that would be negative 5 times negative 10, which is a positive 50. X squared minus 15x plus 50. All right, part D, notice I have a binomial times a trinomial. So FOIL doesn't really make sense anymore because, multiplying the two firsts together, that's great. But then just outside, like then I'm not multiplying by the negative 3y, right? If I jump all the way to the 2. So we have to scrap FOIL, but keep the spirit of FOIL. So remember, FOIL is just another way of saying do the distributive property. So anytime you're multiplying any size polynomial by any other size polynomial, all you have to do is multiply the first term by all 3 of the second term in this case. And then you would do the same thing with the 1. In other words, we're just going back to that distributive property idea. So we're going to do y times y squared, or 2y squared. So that's 2y cubed. Y times negative 3y is going to be negative a 3, and y times y is y squared. Notice how slow and deliberate I'm being. 2 times positive, y times positive 2 will be plus 2y. y. 1, now I do the next one. 1 times 2y squared is going to be 2y squared. So here's an idea. Instead of write it out here, we'll just go ahead and do it, and I'll show you another way to do it. So 2y squared minus 3y, and then 1 times 2 is 2. So now I have to add these together. 2y cubed, I have no other y cubes. I have a couple, let me cross it off so I took care of it. Negative 3y squared and 2y squared is negative 1y squared. 2y minus 3y is negative y. And I have a plus 12. That's one way to look at it. Another way to look at it would be do the multiplication. So we're going to do, this would be the horizontal method. And we're going to do the vertical method over here. So we're going to do exactly the same thing. So I'm going to write down the answer that I got at first. I got 2y cubed minus 3y squared plus 2y. So that was what I got when I did the y, the first part. Then instead of writing the answers down next to those when I do the 1 times, I'm going to line them up according to common terms. So 1 times 2y squared is 2y squared. I'm going to start that right here. 1 times negative 3y, that would line up here, and 1 times 2 would stick out on the far side. Now I'm going to use the vertical method. I can clearly see I have no other y cubes. I can clearly see I have those y squareds. I have those y's, and I have those. Oh, that's not a 12. That's just a 2. Plus 2. All right, that is it for today. Now we have to do is, unfortunately, we have to beat this into the ground. You have to be able to do this instinctively. FOIL needs to be second nature. You need to be able to do it and know exactly what you're doing with minimal error. So practice, 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 and we'll see you in class.